ship moving down London's river is a familiar sight, even when its cargo consists of scientific equipment for an atomic weapon trial in Australia. In August 1953, Parliament lifted the security on Operation Totem. The public were told that 2 atomic experiments would shortly take place. Far from the busy streets, one man had been alone in the Australian desert. His name was Lenny Bedell, and his job for the last 4 months was to find a suitable place for the test. After repeated surveys, he found the ideal spot 350 miles northwest of Woomera, which came to be called Emu. Back in England, scientists and technicians from the Atomic Weapons Research Establishment and government departments interested in the many aspects of the trial were starting on their 13,000-mile journey. After a short stay in Sydney, they went to Woomera, where the final formalities, such as security passes and driving licenses, were completed. Work had been in progress for some months before the trial staff arrived. The tremendous task of store movements went on unceasingly. The site had to be made ready, and many times a day York aircraft of RAF Transport Command were flying the machinery to Emu. These aircraft also flew the scientists to and from the site. Then there were the convoys taking their loads to the men in the desert. These journeys took 4 days over dusty, unmade tracks. Australian troops since early 1953 had been making the place habitable. Water had to be found, and boreholes dug deep into the rock produced a supply which was barely sufficient. They were constantly running dry, and the water contained salt and had to be distilled for drinking. The clay pan, which was used as a runway, had to be leveled. Ditches for cables had to be dug, and roads cut through the bush to establish communications between the different sites where recording apparatus was to be installed. Members of the Australian task force were interested to see the boffins arrive from Woomera. With them came more equipment and stores for the camp, which was under the command of Brigadier Lucas of the Australian Department of Supply. He is here being introduced to Mr. Adams and some members of his staff. The living accommodation was waiting for them. Groups of tents were pitched round the cookhouse, which had to feed over 300 personnel every day for the next 3 months. Tomorrow the work would begin according to the plan, and there was a great deal to do. Hundreds of crates had to be unloaded. All the installations had to be prepared in time for the firing date, which had been decided in England. There were 3 camera towers to record high-speed photographs of the explosion. 30 cameras were distributed between these towers at widely separated sites. In addition to the cameras themselves, heavy-duty batteries for the motors had to be hoisted onto platforms which were as much as 60 feet from the ground. The mechanical effects team had their gauges and switches laid out on the T1 and T2 lines. To ensure faultless operation of the switches, it was essential they were correctly aligned with the weapon towers. Great care had to be taken in connecting them with recording apparatus down the line, and it was no easy job keeping sand and dust from the fine contacts. As in Operation Hurricane, the toothpaste tube gauge was used. Sir William Penny showed at the Bikini trial that petrol cans could be used effectively to measure blast pressure. These tubes, placed in baffles, worked on the same principle. Australian troops were responsible for the installation, and before D-Day, each set was numbered and its position carefully noted. Mustang aircraft were placed at specified intervals from ground zero to test the effect of the explosion on them. Measurements from the mechanical effects team were provided so that damage and blast pressure could be correlated where necessary. A model of a funnel of a daring-class destroyer was built in order to test its resistance to blast. In addition to giving information on weapon design, this trial was used to test service equipment. Various types of ammunition were exposed to the blast. Atomic weapons have not yet made small arms obsolete. The infantry still need support weapons. A Centurion tank was brought over desert tracks from Woomera and placed close to ground zero. The problems of protecting personnel were examined from two aspects. Several types of slit trench were built, and measurements made of the degree of protection given against radiation. Underneath the soft sand was solid rock, which made digging a slow process. The other aspect was civil defense. This device was intended to indicate the direction of ground zero by means of light from the explosion, which passes through the hole in the cover and leaves a mark on heat-sensitive paint. These concrete cubicles are models of possible designs of air raid shelters. Measurements must be made with great care in view of the reduced scale. The laying of cables was an important task. Some of these were heavy. All had to be laid over rough country. This was the main control cable which synchronized recording apparatus with the firing of the weapon. It was hard work for both men and vehicles. Another vital cable transmitted pulses which, when decoded, would give vital information on the fission process. Joins in such an important cable must be perfect to ensure good results on the oscilloscope records, and a foolproof technique is required. While work was in progress, the Minister of Supply, Mr. Duncan Sands, visited the site and personally inspected some of the installations and was introduced to the staff. All through the trial, security was strict. On D-Day, the weapon would have to be lifted to the top of the tower in the half-light of dawn, and this operation had to be carried out smoothly. During these practices, no unauthorized person was allowed near the tower, and the weapon was carefully screened so that no one could see anything which would reveal its size and weight. Some time before the first explosion, Sir William Penny flew to the site. On his shoulders lay the responsibility of deciding the exact firing date, taking into account the prevailing weather conditions. A wrong decision would have meant loss of many valuable records, and possibly even of lives. The weather was not suitable for the explosion on the day that had been decided in England. The wind rose, and for some time blew in the wrong direction. During this time, the first stage of the operation, Phase Dingo, was commenced 4 times, only to be abandoned. Meanwhile, the problems of vehicle maintenance became more acute. The dust and rough tracks took a heavy toll of the Land Rovers and lorries, and mechanics had to work long hours to keep them in running order. These vehicles had been badly strained in the previous months, and deterioration of the roads between the sites was causing further wear and tear on the engines. Adequate transport for D-Day was essential. Meteorological experts checked the weather daily. While scientists were trying to predict the direction of the wind by flag watching, these men were sending up balloons to high altitudes in order to obtain an accurate forecast. Conferences were frequent. A constant check was made on the weather graphs. At last, Commander Westwater, who was head of the meteorological team, was able to advise Sir William Penny that the time had come when conditions would be ideal. It became possible to put into operation Phase Dingo with a fair chance of the weather holding long enough for the firing to be carried out with safety. As soon as the decision had been made, messages were flashed to the back stations. Press reporters were to be flown to the site to watch the explosion. Also, at the appointed time the next day, a Canberra aircraft would take off from Woomera and fly through the radioactive cloud. At sunrise, camera sites are ready. Film is being loaded in the Kerstel Cine camera. This camera uses an air rotor which drives a mirror at 190,000 revs per minute in order to take 500,000 pictures per second. Cover plates are fastened. The film wound on. The last member of the weapon team leaves the firing tower and returns to the control room with the safety key. Safety key in. The firing sequence begins. It is -4 minutes. All the recording apparatus is ready. The wind is in the right direction. Minus 3 minutes. Everything still. Minus 2 minutes. Minus 1 minute. Thirty seconds. Ten. 5, 4, 3, 2, 1, 0. As the first blinding light from the explosion dies away, Sir William Penny at B site waves his hand, and the code word for Operation Successful starts on its journey to England. A high-speed camera running at 200 frames per second at D site shows the ball of fire with its base enveloped in dust. A single frame from this camera shows the expansion frozen by a half millisecond exposure, taken 7 milliseconds after zero. At B site, another high-speed camera shows the shock wave separated from the fireball, which is beginning to contract as its outer layer cools. Meanwhile, normal speed cameras have been running. 2 of these show the later stages of the fireball obscured by the Wilson cloud, which is formed behind the shock wave as it passes through the damp morning air. The upper boundary of the Wilson cloud is defined by a temperature inversion. As the ball rises and cools, air sweeps underneath, carrying more dust into the column. Manually operated cameras on the ground follow the mushroom until it eventually resembles a natural cloud. Meteorological experts measure the rate of rise of the cloud, and their results will be used to predict the behavior of contaminated air in this and future trials. Other scientific staff, whose apparatus has been started by remote control, are able to watch the event from B site. 2 unmanned towers on which the cameras have been started by remote control are also recording the event. The first, D site, is too close to the line of the sun for good pictorial results, but will give measurements to check the symmetry of the explosion. The remaining site, C, is by far the most advantageous from the point of view of lighting. And from here, remote control cameras produce the best overall pictures of the formation of the cloud and column. The mushroom head at this stage is 3,000 feet across, while the column is 700 feet in diameter. The rate of ascent has decreased from 150 to 75 feet per second, and the height of the column is 6,000 feet. The cloud attains a maximum height of 12,000 feet. Some seconds after the explosion, scientists are able to watch the Canberra jet aircraft fly into the cloud to collect samples of fission products before turning towards the sun and setting course for return to Woomera. Immediately after the explosion, plotting of the contaminated zones begins. Those who are to enter into the dirty area have to conform with a special health procedure. Instruments are collected. Protective clothing is issued. Gabardine overalls, rubber gloves, hoods, sweat rags, underwear. Then into the changing tent, where attendants are ready to assist them and to make sure they are completely covered so that no radioactive matter can reach their skin. The fitting of the respirator is very important. Breathing radioactive dust is the greatest hazard of all. The hood makes the final touch. This keeps dust particles from the hair, which is difficult to wash free of activity. Only a few vehicles could be spared to take personnel into the active area, 4 miles away, and instruments are watched closely to check the dose rate. And here is the devastation. The funnel is badly damaged. One cubicle shattered. The tank suffered little damage and was driven away. In the darkroom, prints of the explosion are prepared. Color records were flown to England for processing, and here are some scenes taken of Totem 1 explosion. From the B-side tower, a camera running at normal speed shows the rising cloud grey against the bright morning sky. Shorter focal lengths, used to view the whole of the growing mushroom, cause further weakening of the colours as scattered sunlight enters the lens. In contrast, the high-speed shots which follow show the sky deliberately darkened to accentuate the colors of the ball of fire. As the fireball fades, this camera at sea sight shows for the first time the color of the column. From D site and then from B, the next scenes show the fireball in greater detail, as it is first hidden and then revealed by the Wilson cloud. With the burst above the ground, a cloverleaf pattern is seen from every viewpoint. Now back to Station C, where a normal speed camera gives a record which has been exposed and printed for minimum distortion of color values. The 3 months of the operation have made little impression on the mulga. The rabbits will do more damage in a day than we have done in all this time. Only the aircraft have made it possible for us to live here, and now they are taking us away to Woomera and home.